All right, here we are. Everybody's science now. All right, coming at you with a little science ecology review. A little CNC Music Factory to set the mood here, getting me mentally ready to go over this. So this was your quiz from Friday, or if you were absent, Monday. Rough Monday today. Okay, it felt like a Monday. I hope it wasn't as tough on you guys as it was for me. But hopefully you guys got caught up today. But anywho's, a little stylus check here. I'm gonna draw a blue tree. There we go, and we'll draw some roots in there too. You know, get some ecology going there, some abiotic factors and water and stuff. All right, now let's erase that. All right, so what I want to do here is go over your quiz in more detail than I was able to in class, which is basically saying 1 is A, 2 is B, 3 is C, 4 is D. Okay, that's not good enough for me. I want to give you the option of understanding why it was A, B, C, and D. Okay, first set, okay, nothing crazy. I was hoping everyone would get a 5 out of 5 here. Wasn't trying to trick you, just an example of each one of these. So, what's the best way to do it? Well, you could either go this way to that way or that way to this way. So why don't we do a different way? Let me show you a different way. A lot of you might look at population and go that way. Let's go here and then see what it sounds like. There are algae, fish, and gulls in a lake. So what do we have here? We've got different types of living things, algae, fish, and gulls. So when you have different living things in an area, it's a community. So community is A, all right? Nice little lake there. It sounds very relaxing, some algae. I don't know about the algae. I don't want to swim in algae. It's pretty gross. I've done it before. In Illinois, yeah, we've got a lot of algae lakes, and yeah, it's bad. Don't do that. They have parasites. Anyway, what else we got? Oh, moose. All right, so I was hoping for everyone to get this one, so I'm hoping you didn't miss it. But if you did, don't feel bad. You know, mistakes happen. That's what I'm here for. That's an individual. One individual moose. A forest has 129 moose. First of all, moose are very dangerous. Like, they are big, aggressive animals. So if you see a moose, run away. Don't try to pet it. It can kill you. There are more moose deaths like by any other animal like in the country. Now, most of them are in Alaska, so I don't have to worry about it in Las Vegas. But it's 129 just moose. So it's just moose. So it's a population of mooses. Mooses, mices, whatever, mouses. I don't know. Ecosystem. Ecology is not my specialty necessarily, but I know enough. Get it done. Anyway, an island that contains reptiles, lush soil, plants, humid climate. Oh, is that nice? This is where I want to be right here. Lush soil. Well, I don't know about the humidity. I take that back. Okay, so we've got biotic factors, plants, reptiles, all right, little gecko or something. And now we're adding abiotic factors. Okay, did some crazy stuff on me. Anyway, you take abiotic plus biotic, you get community. Abiotic, a little math equation. And habitat. That's the specific place in an ecosystem that an organism lives. Like frog pond. Is that on here? Oh, look at that. I didn't even know it was frog. I got to stop using frog. I like frogs. And deer. And wolves. Frog lives on the shores of a swamp. Okay, that is the habitat of the frog. Shores of a swamp specifically. All right. So hopefully you get 5 out of 5. But if you're watching this, good chance you missed some. So don't mix those up on the next one. I'm not gonna really try to trick you again. All right? I'm coming right at you. Anywho's. Oh, this little bugger. You will see something very similar to this. I'll probably just mix up how I do the picture. All right. I'm testing your ability to understand now, apply what a population is. So if you got that one right, you still might have got this one wrong because, it's possible you still don't understand fully what a population is. The key to a population is in the same area and can interact. So a lot of people are like, Mr. Abling, the answer is not here. The answer is 5, 6, I want to say 8, or 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, or 6. All right, there's 6 populations total. But you got to read the question. How many populations of smileys? All right, smileys. So we have 1 clump here. Now, this is where I tried to trick you. All right, I did this on purpose because I thought some people who didn't know the definition very well. So there are 3. Look at that. I got 3 populations of smileys. 1, 2, 3. Bam, got that one right. Wrong. Okay, wrong. Red. Okay, this is one population. This is one population. Mr. Eibling, why? Well, there's a Grand Canyon here. And I don't know if you've ever been to the Grand Canyon. Not that far, actually. I'm pretty pleased moving here, how close it is. You can't really go across it if you're a smiley creature. Okay, but if you are a bird, even a bird, would not really be part of its normal mating thing across the Grand Canyon. So this is one population of smileys. Okay, because they interact with each other over here. That smiley maybe goes to that one, and they make babies, but they don't just walk across the Grand Canyon. Same thing with the hearts. Okay, there's one population. There's two populations of everything here. If I took away the Grand Canyon magically, okay, then you'd have one population. So then this heart could go over to, or that smiley could go to that smiley and have smiley babies. Hopefully, really smiley, like super smiley. That'd be nice. One can, sometimes it doesn't work that way. You have two tall parents, a short kid. And we'll learn about how that works later in there. Anyway, a lot of us miss 7. And maybe just because there's a lot of words and stuff. That's my guess. So the answer is ecosystem. So let's see what we have here. Why is it? Species. Maybe you didn't understand what a species was. It's possible. It's possible maybe you didn't understand what a species. Species are living things. I think most of us knew that. But if there's something like that and you're not sure, if it wasn't a vocab word that I wanted you to know for a quiz, ask me. What is a species again? Sometimes I'll tell you. Sometimes I'll be like, I wanted you to know that. But in this case, I probably would have told you. With abiotic, so species plus abiotic. Like a little red, white, and blue here going, a little America. Now we got biotic plus abiotic. Well, I gave that to you earlier. What is that? It is an ecosystem. All right. So a lot of us missed that. All right, 8. I ain't messing around with this. It's the sun. Okay, you got the sun up here, and all the energy. Mr. Abilene, why is your sun blue? Well, all right. Tell you what, I'll make yellow sunlight. All right. Yellow sunlight. That's the energy. Mr. Abilene, what about food? Oh, we got a black plant. The fruit in the plant. All right. That's food. Well, the energy to make that, let's say, I don't know, what do you want, a pear? Pear. You ever had a pear? There are a lot of pears out here? I don't know. But this orange, which is black, it doesn't just, the energy to make it, okay, you can't just make something without energy. Making an orange takes energy. Where does the energy come from? The sun. So ultimately, all the energy comes from, circling again, the sun. The most similar word below to a producer is autotroph. They're like the same thing. I can't even begin to describe the difference. So, yeah, just remember autotroph, producer, producing, making something. Auto, yourself. You automatically do something. That's kind of the best I can do for you on that memory trick. I'll work on it, though. All right, so remember I told you to draw these out, like a number 10. So we got a plant. Mr. Abilene, don't make a black plant again. All right, I'll get a green going here. That looks pretty green. All right, so we got a plant. All right, that's pretty planty. All right, we got a grasshopper. Oh, boy. I don't know how to draw a grasshopper. Give it some wings. Okay, grasshopper. Okay, all right, comes in, eats the plant. He is now a primary consumer because he ate something. He's consuming, or she, I don't know. Could be a she. We'll say she. She eats some of the plant. She is now a primary. Primary means first. She is the first eater of this food chain. All food chains start with a producer. All right, now we got a frog. Once again, another frog coming along. All right, really can't draw a frog. I really can't. I don't even know. I'll draw a frog face. A bit long tongue. Froggy. All right, give him some spots, black spots, right? Frog, right? They have warts on them and stuff like that. All right, so that tongue slurps up the grasshopper. Crunchy. It now ate the primary consumer. So it's up one level on the consumer chart. It's a secondary consumer. Boo yizzle. What if something ate the frog, Mr. Abilene? What if a bigger frog ate the frog? That's possible. That would be a tertiary consumer, which is shown there. It's cut off. I know. I'm sorry. Anywho's. All right. Let's go to the next page, shall we? Boom. We didn't go to the next page, did we? No, we didn't. There's nothing on this page. I need to go back and fix it. In trouble here. There it is. I found it magically. All right. Let's get her where we can see it. Okay, so what you could do instead of just staring at it, why don't we do this? Let's look at each level. We've got our producers. Always producers at the bottom. We got our primary consumers, our first eater of that. Then we got our secondary, tertiary, and then quad four, quaternary. All right, our fourth level consumer. Part of the energy pyramid above would plants be in? At the bottom, always at the bottom. Never put a plant up here, all right? And someone asked me about Venus flytraps today. That's maybe I'll get something a little on that. Now, they're interesting critters, but they're not. They're still producers in a lot of ways. So that would be Carnivore eats a primary consumer. So like the lion eats deer. I gotta stop killing deer. Right? I really gotta come up with more primary consumers. I gotta expand my repertoire. Carnivore eats a primary consumer. What part of the above pyramid the carnivore be in? In order to be a carnivore, you need to be at least a secondary consumer. See what you are. You are a primary consumer right here. So this is where our primary consumer is. All right. We'll say a mouse. Yeah, we eat enough mice. Okay. We eat the mouse. And we'll say the owl eats the mouse. Owls are deadly carnivore hunters. Part of the above pyramid would the carnivore be in? It is now in 8D, so that would be it's in C. All right. Very nice. So here's an example of parasitism. All right, so parasitism is one benefits. I don't know why I put a comma there. One harmed. And that's the gist. But they both stay alive. Dying is not being harmed. Okay, so that's kind of where I wanted maybe to get you. Is this one probably maybe thought, well, that's grasshopper is eaten by a frog. The frog benefits by getting energy. The grasshopper is definitely harmed. It's dead. Okay, it's not harmed. It is dead. It is gone forever. It's energy. Some of it goes on to the frog. But anyway, the answer is B. Okay, the worm is going to live inside the stomach of an animal and just slowly take its energy away. It doesn't want to kill it. You don't want to kill the host for your parasite, because if you kill the host, you've got nothing to feed you now. You got to go find another stomach to invade. So that's why parasites try not to be too deadly. Same thing with viruses, and we'll talk about viruses and how they evolved to be just deadly enough to do what they need to do. But anywho's, all right, I gave you this graph. All right, so we kind of went over it a little bit. Part of the above graph would be an abiotic factor. So kind of quizzing your vocab and graph reading skills. Abiotic means non-living. So what this graph is showing is this non-living rainfall affecting the population of these three plants. So it is rainfall. Population size. Population size is biotic. It's populations of living things, not a population of rocks. We don't classify the population of dirt. A population of living things. All right, there you go. And plants are obviously biotic factors. Yes, plants are alive and they have feelings, so don't hurt their feelings. Yeah, they're a lot like us. They share like 70% of our same genes. You could have a plant gene inserted into your body and it'll do just fine. That's kind of crazy. We'll talk about that again later. I love genetics. That's my thing. Which of the following is the best conclusion about the above graph? Let's look at each choice, shall we? All right. Instead of just going to the right answer. Well, the right answer is, well, I already probably told you, but anyway. The population of plant A, let's look at it, affects the population, or long day, I told you these Mondays. Population of plant B affects the population of plant A. So that means is, let's say population of B goes up. That means something's going to happen to the population of A. It might go up too, or it might go down. So let's look at B. B is the straight line. It doesn't change much. It's virtually the same. So plant A shoots up right here, while plant B is basically doing nothing. It's just keeping the same population. Okay, virtually the same population. It doesn't look like no matter what B is, it's always the same. A changes rapidly. So what happens is A affects C and C affects A. They're related here. So as A goes up, C goes down, and then C goes up, and then A goes down. So they're direct competitors is what they are. They're competing for the same space or resource. So plant B, though, is different. It's probably easier with animals to think about it. Like lions and tigers competing for the same food, right? Like gazelles and buffalo and things like that. But if B is a mouse, it doesn't care if there's enough deer or buffalo. If the lions start populating and start eating all the buffalo, all right, that's going to hurt the tigers. But mice aren't going to be affected by an increase in lion population. Okay, lions aren't going to hunt mice. It's just not enough energy to chase after it. A dead mouse it might snack on, a little. It would be like a Snicker bar for us. A lion eating a mouse would be like just eating a Snicker. It's not going to chase it around, wasting energy. Remember, it costs energy to get it. So if it's going to cost more energy to eat the mouse than it is the mouse is going to give you, a waste of time. You could die from that if you're a lion. Anyway, more rainfall increases plant populations. This sounds good. Like if you didn't know, you'd say, "Oh, that sounds right. More rainfall increases plant populations." But let's see what happens. If that was true, the graph would look like this. Every plant would go up. I would agree with that, but that's not what we see. At some point, population starts dropping. It floods. Okay, too much rain can kill you. So just because it's more rain here is helping doesn't mean that more rainfall increases population. Okay, so that's a little general. Now, if I cut off the graph, okay, and just saw like cut off all this, all right, and we just saw that, okay, then that would be a good answer. So the answer to the hardest question on the test is D. Plant B is not as affected. Look at it. I'm slaughtering the graph. It doesn't care if it's dry. Okay, it's got about the same population when it's really dry rainfall compared to here. Very little changes. It doesn't care. It's not that dependent on water. It means it's probably very drought resistant. If a drought hit, okay, it would probably do very well. Probably very well. So probably the best drought plant, like a cactus or something. All right. Oh, one more to go. Oh, this guy, little bugger. If you are A fun, you are not fun. So what am I testing here? I really hammered the fact that if you put the letter A in front of a word, it means without. So hopefully you got this right, because that means you were paying attention in class. I'm not saying you weren't paying attention, you got it wrong, but you might have just been confused. If you are A anything, you're without it. So if you are A dumb, that's probably pretty mean. Actually, no, that's good, because if you're A dumb, that means you're not dumb. So I would never call you dumb, but I would call you A dumb. A dumb. Okay, that means you're not dumb. If you're lovely, oh yay, I'm lovely. Yay. You are A lovely. You are without loveliness. That's pretty mean. You got to really not like someone to call them A lovely. But anyway, that should wrap this puppy up. Watch this. Well, why am I telling you to watch it? You just did! Because you got a retake on Wednesday. So if you watch this tomorrow, then you have a retake tomorrow. All right, so retake Wednesday. If you have any questions on any of these questions, if you have a question on the question, ask me, and I will maybe give you some more details. So, the code word for this video is going to be, what's a good word? I was not prepared. Oh, how about sunglasses? Because I'm looking right at them. What an uncreative word. Way to go, Mr. Eibling. Sunglasses. Tell me that tomorrow. I'll get you a ticket. All right. I'll get water. I'll get a bottle of water for you guys. You guys are thirsty. You guys are killing me today. All right. Check it out. Go watch some Monday Night Football.